So good morning everybody and welcome to this presentation. Today I'm going to talk about how we go towards the full deployment of corrosion-free concrete structures. So how we, what is it? That's not it. Sorry, thank you for that. Okay, so before starting with the presentation, let me set you a little bit in context. So please raise your hands, all those that suffer traffic delays here in Miami. All of you, right? Don't be shy, come on. So mainly all these traffic delays are mainly caused by the repair work that takes place in our bridges and roads. So our bridges and roads are mainly made of steel reinforced concrete, which is a steel reinforcement with concrete. What happens is that in areas such as Miami, where we are close to the water, this steel reinforcement gets corroded, leading to the deterioration of the whole infrastructure and leading to these repairs. And here in the US, per year, we have more than $22 billion cost in these repairs. So there are many other universities that are working, trying to reduce these delays. What we do here at the U, we always go one step further. So we just try to get the corrosion out of the equation. So how do we do it? Using another type of reinforcement, which is glass fiber reinforced composites. So as you can imagine, I mean, we cannot be here 100 years testing all these materials to check the durability of them. So we have to use some tricks, and in this case what we use is the accelerated aging. So we put all these materials, this reinforcement that is going to replace steel, we put them in these magic chambers, what we call magic chambers, that are chambers, in our case, they are filled of seawater and at high temperature. So we are going to use three types of three temperatures, 23, 40, and 60 C. And we are going to leave this material for 60, 120, 210, and 365 days. So after we leave the material for that time, these chambers at that high temperature are going to kill the material. So what we need is we need to check the properties before and after this accelerated degradation. So we do a lot of testing. We do mechanical testing such as tensile tests, different shear tests, also bond to concrete, since it's a very important parameter. And we also go a little bit more fancy. We go also to the microstructure. We do SEM, which is scanning electron microscopy, and we check in the microstructure how that durability is affecting, how that degradation is affecting, and if there is a big difference between the pristine or the material that comes directly from the manufacturer and the material that it's aged. So afterwards, what we do is, so now we have the accelerated aging, now we have to come up with the relation with that accelerated aging to the real life. For that, we use some complex mathematical models, such as Arrhenius relationships, that relate that extra, like high deterioration to the what does that mean in the real life. So what we saw out of this research, it's not completed, but we have a lot of data that we can take some preliminary conclusions. So until now, there's no deterioration, no major deterioration. So we are proving that the durability that this material, that we say that this material has, it's there. So we see that we have different materials, different manufacturers that produce different bars, and each of them have different properties, but all of them meet the durability standards. However, we are claiming that there is a need for the standardization of these materials, since it's going to be better for its commercialization. So, and here is the most important part of this project, that it has a great impact in our society, since right now this material, the Florida Department of Transportation, who is very interested and it's funding this project, they are not allowing to use this material in structures directly in contact with seawater because there is not enough research. However, they are funding this project since they want to see, after all these tests are done, if the durability is proven, then they will allow the use of this structure, of this material in, for example, seawalls. As you can imagine here in Florida, all the hundreds of miles that we have of seawalls, that we could have them corrosion-free by using this material. So this is the end of my presentation. Thanks so much, and please keep an eye on this technology, because when it goes, it's gonna go hard. So thank you so much.